Hello class. You probably noticed that this is a different video format than the previous videos I've posted, and that's because, well, because of the coronavirus, a lot of places have shut down, including all of campus, so I'm not really able to access any real whiteboards. So we're just going to have to go with this format and do the best we can. Okay, so this topic is solving trig equations in applied problems. So I'm just going to teach this by doing an example. This particular example is on page 642 of the book, problem number 105, if you'd like to follow along. Basically it says the blood pressure, P, in milligrams of mercury of an individual after t seconds can be modeled by this equation. So P is equal to 100 plus 20 times sine of 7 pi over 3 times t. Okay? And then there's three parts. Part A asks, in the interval 0 to 1 inclusive, find all the times at which the blood pressure is 100 milligrams of mercury. Okay? So basically, find when the pressure is equal to 100. Okay? So this is going to be just plugging in that p-value to our equation and then trying to solve the equation for t, because we're trying to find when, which is the time that this happens, right? So that we're just going to write our equation with the 100 plugged in. 100 equals 100 plus 20 sine of 7 pi over 3 t. Okay? Subtract 100 from each side, and then divide each side by 20. If you do that, you would get 0 equals sine of 7 pi over 3 t. Okay? And now this is our similar technique to before. You ask yourself on the unit circle, where is there a sine value of 0, right? So that's only happens at two places on the unit circle, which is at 0 and at pi. So basically we're saying that the inside of this sine function, we're treating that as our whole x, right? So it's that inside of that sine function, so 7 pi over 3 t, would have to either be equal to 0, plus the extending that by the period of sine, which is 2 pi n, or pi plus 2 pi n. Okay? Now we have to isolate that t, so let's divide both sides of the equation by the 7 pi over 3. Okay, so isolating the t, we get t either has to be, let's see, so the first one is just 2 pi n. Okay, dividing that by 7 pi over 3, that's like multiplying by 3 over 7 pi. So the pi's would cancel out, and you'd have 2 times 3 is 6, so 6 over 7. Okay? 6 over 7n. Okay, so the n is still there. And I'll talk about what that means in a second. Okay, and then the other possibility is, okay, taking this pi, dividing that by 7 pi over 3 would give me 3/7. 3/7 plus, and then the 2 pi also would be plus 6 over 7n. Okay? So this still represents an infinite number of answers, right? Because the n can represent any integer multiple, so that could be 0, 1, 2, 3, or -1, -2, any negative number, any negative integer. So, but do we really include all of these in our final answer? No, because the question specifically asked only in interval 0 to 1. So you have to figure out which of these infinite number solutions actually meets this criteria of being in interval from 0 to 1. Okay. So, for example, let's take both of these possible solution sets, right? Because each of the things I just circled represents an infinite number of solutions. And let's figure out which values of n actually give us a solution in that interval between 0 and 1. Okay, so let's do the first one first. So I know that for n equals 1 for here, that will give us 6 over 7, right? So that's going to be one definite answer because that's between 0 and 1. Okay, but if I choose any other integer, except, well actually, n equals 0 does work, doesn't it? Because n equals 0 will get us t equals 0. So that's another possibility because that is technically in the interval 0 to 1 because it includes 0. But then any other integer will not work. Okay, so if I choose any negative integer, I'm going to get a negative value, which is not in our interval. If I choose a positive integer greater than 1, I'll get, for example, 2. 2 times 6 over 7 will be 12 over 7. That's greater than 1. It's not an interval. Same thing for any other greater integer. So that's going to be all the possibilities I get from that first guy. Okay, but then the second guy, 3/7 plus 6 over 7n, let's experiment a little bit. Let's start with 0, like plugging in 0 for n, because that's a really easy place to start. So if I plug in 0 for n, does this evaluate to a solution in the interval 0 to 1? If I plug in 0, I'll get 3/7 plus 0, which would be 3/7, and that is in the correct interval. So we're going to keep that solution. Now let's try to branch out from 0 for n. Okay, so let's try a negative number. If n is a negative number, say -1, will we get a workable solution? Well, if n is -1, we get 3 over 7 minus 6 over 7, which would equal -3/7, and that's already getting below 0, so that's not going to work. We can't use any negative numbers. They're going to be too low. They're going to be below 0. What about a positive number? Let's try using n equals 1. If we use n equals 1 over here, that would be 3/7 plus 6/7, which would be 9/7, which is greater than 1. So that's not going to work either, and any greater integer for n in that situation would also be too big. So we found 3 possible solutions. T is equal to 6 over 7, 0, or 3 over 7. This was, what unit was this? This was in, T was in seconds. So T could be 6 over 7, 0, or 3 over 7 seconds. Part C says, also still in the interval 0 to 1, determine the times at which the blood pressure is between 100 and 105 milligrams of mercury. Okay, so 100 between, it doesn't say, between doesn't really mean, it doesn't really tell you whether that would include or not include the 100 and the 105. We'll just say it does. I think it's ambiguous on that point. Okay, so basically I chose the less than or equal to instead of just the less than. I think it's ambiguous on that point, so if you did it either way, it would be acceptable. Okay, so we're basically solving this. Okay, so when is the pressure greater than 100 and less than 105 milligrams of mercury? Okay. Well, we already found the time. In part A, we already solved when P was equal to 100, right? On the time interval 0 to 1, right? And those times were, let's go back and look. I think I still have it pulled up here. Okay, that was 6 over 7, 0. Let's put it in order: 0, 3 over 7, and 6 over 7. Okay, 0, 3 over 7, and 6 over 7. Okay, so those were the times when the pressure was equal to 100. Okay. Now let's go and find the times when the pressure is equal to 105, and then the interval in between those times must be when the pressure is between those two numbers, right? Because pressure is continuous, right? It can't just like jump above a number without passing through all the numbers in between. Okay. So let's go and solve for when P is equal to 105. We'll do that now. So if P is equal to 105, what does that mean for T? Okay, let's solve it. 105, plugging this into the equation, is equal to 100 plus 20, and running out of room here, times sine of 7 pi over 3 t. Okay, again, solving for t, we have to subtract 100 and divide by 20. That would be 1/4 is equal to sine of 7 pi over 3 t. Now I'm glad we're doing this example because you can see that 1 over 4 is not a common multiple sign value, right? You wouldn't be able to find that on our common multiple unit circle. So this is going to be an exercise in doing an approximate trig equation. Okay, so we're going to have to use our calculator to basically cancel out this sign and get the inverse sign value over here. So basically, I'm just going to write out what I just said. What we need to do is we need to take the inverse sign of both sides, okay, to get one possible answer. Remember, this only gives us one possible answer, and that there might be more than one. So canceling out this regular sign, using the inverse sign to cancel the regular sign. Oops, t. Okay, so I'm just going to go to my calculator right now. Okay, I make sure that my calculator is in radians, and then I do inverse sine of 1 over 4. Okay, and I got a decimal value that rounds 2 decimal places to 0.25. So 0.25 is one answer, right? Is one answer for what the inside of the sine function, the 7 pi over 3t, has to be equal to. Okay, but maybe there's probably more than one, right? So let's use our knowledge of the unit circle. If you want, you can draw it out. So having a sine value of positive 1, 4 would be a y value of about right here. Okay, so you can see that there really should be two answers just on the unit circle between 0 and 2 pi. Okay, and the one that we found, which one would the one we found have to be? It would have to be this angle that I'm drawing right here, because remember that the range of inverse sine is only in quadrants 4 and 1, right? Between negative pi over 2 and pi over 2 radians. So the solution we just found must be that one there. Okay, so that means that the other solution is all the way over here. Sorry, it's hard to draw with this. It must be that solution. Okay, and the way that we would kind of reason what that is, all right. So we can put an or over here. Think about going all the way to pi radians and then going back by the same amount which we went forward for the first solution. So that would be pi radians minus, because that's going back, 0.25. Okay, so those are the two possibilities on the unit circle, and you need to think about both of these because both of these solutions, either one of these or both of them, could give us solutions that we ultimately care about in our final answer, right? Okay. Now go and isolate your t, right? So we still have this 7 pi over 3t. So let's change that by dividing both sides by 7 pi over 3. Okay. And now, since we're already dealing with decimals in this problem, oh, by the way, we are dealing with decimals. I probably should have included more decimal points. So let me go back and do that. A third decimal point would be putting a 3 at the end, because we haven't yet reached our final answer, right? We're still doing more calculations. So I'm including a third decimal point for greater precision. And in the final answer, we'll have just 2 decimal points, 2 decimal places. Okay, so this is an approximate. So I'm just going to use my calculator to get an approximate calculation for both of these. Again, I'm basically dividing by 7 pi over 3, which is the same as multiplying by 3 over 7 pi. I totally forgot to extend these by 2 pi n, which was the period of sine, right? So let's just work that in now. My apologies. So I'm just going to add 2 pi n to both of these. Okay. All right. Now, let's go and divide both sides by 7 pi over 3. So 2.53 divided by 7 pi over 3, divided by 7, and then multiplied by 3. Okay. So that is the 0.35. Okay. And dividing the 2 pi by 7 pi over 3, I think that was the, excuse me, 6 over 7n, right? Okay. And then the second answer would be, okay, it would be the same thing, except, so we still have the, well, hold on, let's be careful here. So I'm subtracting the 0.35, okay. I am still adding the 6 over 7n, but then I also got this pi term right here, okay? So that would be positive pi divided by 7 pi over 3 would be positive 3 over 7. Okay? All right. So those are our infinite number solutions, but now we need to, well, now we need to determine which ones actually matter on the interval from 0 to 1, right? Okay? So let's do that. Between 0 and 1. Okay, so from the first set of possible solutions, I think definitely if we take n equals 0, that will get us 1 that's valid, so 0.35. No negative ends are going to work. That would give us a negative answer, which is wrong. Okay. What if we do a positive 1, though? I'm going to try plugging this into my calculator to see if it works. So 6 over 7, and then adding that to 0.035. Okay, that actually works too. So I actually got 2 solutions for my first set of possible solutions, 0.89. Okay. Now let's see if the second set of solutions gets us anything on the interval from 0 to 2 pi. Okay, if I plug in 0 for n, that's going to be too big. I can see that right away. Oh wait, no it's not. Hold on, the second term is going to cancel. Okay, so if I plug in 0, basically the second term goes away, and I'll have this negative 0.35, adding that to 3 over 7. And then I calculate that as 0.39. Okay, so that's going to be another good answer. Okay, so that was for n equals 0. What about n equals negative 1? That's not going to work because that will be negative. What about n equals positive 1? That will be too big, okay, because that will be greater than 1. All right, so those are going to be the 3 answers for p equaling 105. So now we just have to get these, compare these to the other answers we had previously, okay, and kind of maybe just put it on a number line, and we'll see what areas of the number line actually satisfy our condition of being between 100 and 105. Okay, actually forget the number line. I thought of a better way to do this. Take out your graphing calculator, and I don't really have a graphing calculator the same way that you do physically, but I'm just going to use this website to demonstrate, but you can follow along on your physical graphing calculator. So go ahead and type in our equation for the pressure, right? The pressure. So instead of P, obviously use Y, and then instead of T, you're going to use X, but pretty much it's the same way. And then hit graph, and if you're like me, you'll probably get a screen where nothing shows up, and that's because your window is probably totally wrong. Okay, so we need to go fix our window. And it's going to look a little different for you, but let me go to the settings on this grapher. Okay, what you want to go for the window is you want to find the things where it says Y min and Y max, and also X min and X max. So that's going to define what parts of the Cartesian plane are going to be shown on our graph. So let's do the x-axis first. So the x min should be, let's see, well, we only care about the interval 0 to 1, right? So our x min should be 0. That's like the minimum time is 0, and then the x max should be 1. So that's pretty easy. Okay. Now the y min and the y max. So what should these be? So remember, this is actually the pressure. So we think the pressure should probably be somewhere between, what do you think? Well, looking at the function, and it's going to be probably at least 100, but then it's being added by 20 times the sine function. But remember, sine is always between -1 and 1. So really, this whole thing is going to this term, this 20 thing, is going to alternate between -20 and +20. So adding 100 to that, it's going to alternate between 80, 100 minus 20, and 120. Okay, so our y min should actually be 80, and our y max should be 120. So I'm going to put that in. 80 is the y min, and the y max is 120. All right, so that's looking a lot better. This is going to be a lot more useful. But now you can even do something even cooler on your graphing calculator. Okay, in addition to the sine wave that you just graphed, go ahead and add another y equals. So where it says y2, go ahead and so go back to the y equals. For the y2, we care about two values of p, right? Because p is kind of standing in, y is kind of standing in for our p. We care about when p is equal to 100 and when it's equal to 105. So let's type when p is equal, or y, p, same thing, is equal to 100, and then for y3, so another equation, y is equal to 105. Okay, so that shows up as two horizontal lines on our graph, And this is going to be really helpful for determining what's in between, the p-values that are in between 100 and 105. Okay, so if you look at your graph, this really helps us quite a lot. Okay, you can see that right here where my cursor is, that's going to be a place where our p-values between 100 and 105. Also right here, and then right here. So we have 3 spots. So now we just need to identify which of those t-values that we got correspond to these 3 parts, and it shouldn't be too bad. Okay, if you put your t-values in order that we found. So let me go back to the drawing board here. Okay, all the t-values we found were in order. I'm putting these in order. 0, 0.35. The next one is 3/7. No, the next one is 0.39. The next one will be 3/7, but that converts to a decimal of 0.43. And then the next one would be 0.86. And the last one is 0.89. So putting those in order, you can really see which t-values those have to be on this graph. This one has to be the first one, so that would be t equals 0. This one would have to be the t equals 0.35. This one would have to be, what is that, t equals 0.39, and so on and so forth. Okay, so really, all we have to say for our answer is t has to be between these two, or between these two, or between these two. So let me just write that out, and that will be our answer. So t, we could say just in, okay, the interval 0 to 0.035, or, this u means or, right, in interval notation, or t has to be between the 0.39 and the 0.43. Finally, or the t value can be between 0.86 and 0.89. And there you have it. A long problem, but it really taught you a good analysis of these inequality problems. Also just solving the equations, even if they're approximate equations, using trig functions and inverse trig functions.